Right. So welcome back to the session. So today topic is angle of inclination. This is a friction part 2. So for part 1 link I have given in the description. So kindly click the link and watch the part 1. So coming to the topic. So angle of inclination, right? So it is defined as the angle with which the resultant of limiting friction and normal reaction makes an angle with normal reaction. So look at this diagram. So this is the normal line, right? And this is the friction, because whenever a force is acting forward direction, friction will be developed in backward direction, right? So the resultant of limiting friction. So this is the resultant of limiting friction and normal reaction makes an angle theta with normal reaction is called angle of inclination. Okay. So coming to the explanation part. Let us assume this is the object which is initially is at rest state. So whenever the object is at rest state, the total weight mg will be acting vertically downward direction, right? So this weight which is exactly balanced by a normal reaction which is exactly upward direction. So normal reaction is balanced by mg, isn't it? Now I applied some external force along positive x-axis direction like this. So due to this external force, object also moves along with the direction of the force. So that is very well clearly. So whenever an object is moving, there must be a friction was developed in opposite side, right? So here friction also a type of vector and the normal reaction also a type of vector. As we know that parallelogram law of vector addition, if two vectors which are joined tail by tail, so this is one vector, so OA is one vector, OB is another vector, right? Now let us assume the pen is one mirror, okay? Now, so this is the OB vector, right? So exactly the mirror is placing opposite to this OB vector, then what will happen? The image of this vector will form here, isn't it? So these imaginary lines represents the image of this vector. Similarly, I am removing this mirror and I am placing exactly opposite to OA vector. So therefore, again OA image will be formed here, isn't it? So the imaginary line represents the OA vector, okay? So these two imaginary lines coincide at a particular point. The point is called C, isn't it? So I am connecting a line from C to a middle point. So this line will give the resultant. This line is nothing but a diagonal line will give the resultant of angle of inclination. Okay. So from this I am going to take OAC triangle. So from triangle OAC, from this I am going to use tan theta. What is the tan theta? Opposite side by adjacent side, right? So OAC, what is the opposite side here? This is the theta. Opposite means AC. AC by adjacent means this one, OA. That is equal to, here AC value must be equal to OB, right? Isn't it? So instead of AC, I am taking OB by OA. Okay. So tan theta is equal to, OB means what? So this is O and this is B. OB is nothing but friction. What is the friction here? Fs. Divided by OA means, OA is nothing but normal reaction. So tan theta is equal to Fs by N. Okay. But we know that in types of friction in part 1 we discussed, that is limiting friction or kinetic friction, Fs by N is equal to mu, isn't it? Because mu is equal to Fs by N. So let us assume this is equation number 2. So instead of Fs by N, I am going to substitute mu. So substitute equation 2 in equation 1. Then what will happen? Tan theta is equal to mu. From this, bring this theta as it is the same side, and tan theta you just take right side. So theta is equal to tan inverse of mu. Okay. So this is the angle of inclination. So in this topic, easily we can calculate resultant force exerted by the surface on the block. So let us see. I told you already parallelogram means this is the resultant, right? So this resultant square or resultant is equal to under root of this vector square plus this vector square. So what is the resultant here? OC. So OC square is equal to OB square plus OA square. OB square plus OA square. So instead of OC, what is OC here? OC is nothing but R. Resultant R square is equal to OB square means OB value is Fs. So Fs square plus OA means normal. So normal square. So take the square right side. R is equal to under root Fs square plus n square. Okay. Look at here. This is the Fs, right? So from this Fs is equal to how much? Fs is equal to mu into n. Mu into n. Okay. So here normal reaction is balanced by mg. So mu into mg. So instead of Fs, I am going to use mu mg here. So resultant R is equal to mu mg whole square plus normal reaction means mg. So mg whole square. Look at here. Here also mg square present. Here also mg square present. Take one mg outside. Mg into what is the remaining under root? Mu square plus 1 square. Okay. Suppose if coefficient of friction mu is equal to 0. So substitute mu is equal to 0 here. Therefore, R is equal to mg into under root 0 square plus 1. This is nothing but R is equal to mg. Okay. So I hope you understand. Thank you. Thank you so much.